Hello guys, welcome back to the channel. I'm your host Liam, and today we will go over 2D kinematics. So first of all, before watching this video, please go watch the 1D kinematics video because I will be going off that basically. Okay, so first of all, the most important thing to know about 2D kinematics is vectors. So let's imagine we have a velocity v at an angle theta, right? The horizontal component is v cosine theta, and this vertical component will be v sine theta. That's basically all you need to know. You can split the vector into its components, and this is very useful in 2D kinematics. And basically, the horizontal can be represented as vx, the vertical can be represented as a vy. So now with this, we can start to go over projectiles. So basically, a projectile is an object which is at an angle, which is moving at an angle, and is only being affected by the acceleration of gravity. So let's say it's vy is some number, its vx is some value, its ax is 0 since it's not moving, it's not accelerating in the x direction, and its acceleration in the y direction is just negative g, which is negative 9.8 meters per second squared. And that's basically all I have to know. Basically, 2D kinematics are just 1D kinematics separated into two little problems. It's one problem in the y direction and one problem in the x direction. You just split the 2D kinematics problem into two 1D kinematics problems. And hopefully this will become more clear as I do the practice problems. Alright, so now I will go over the first practice problem just to give you guys an example. So Tom throws a stone off a 100-meter tall cliff. So we get that the delta y equals negative 100 meters. And Vx equals 10 meters per second. Since the thrown velocity is 10 meters per second. So we also know that for these problems, these are all projectile problems, which means the acceleration in the y direction will be negative 9.8 meters per second squared, and the acceleration in the x direction will be 0. So now, we need to first find the time. We can use the delta y equals negative 1/2 or positive 1/2 ay squared, since the since the initial velocity in the y direction equals 0, since it is only being thrown horizontally, it's not being thrown vertically in any way. So basically, you can change this to t equals root 2 times delta y over acceleration in the y direction, and this should equal root 200 over 9.8. And this equals, sorry, this is interesting, this equals 4.5 seconds. Now that we know the time, we can use that the velocity in the x direction, since there's no acceleration, in the x direction, the velocity in the x direction will be constant. Vx equals the change in the x, the delta x over the time. You can rearrange this to get that. You can rearrange this to get that. Delta x equals Vxt equals 4.5 seconds times 10 meters per second. And this should equal 45 meters. So that's how far the stone will be from the from the base of the cliff, basically, roughly. So then now take a couple seconds to solve the question on the right, and yeah. So hopefully you've taken some time. Now, okay, we'll solve it. So first of all, this arrow is fired at a degree of 30 degrees at a speed of 10 meters per second. So now this will just be 10 cosine 30 and 10 sine 30. So now we get that. Sorry, I'm bad. This is triangles. Okay. 10 meters per second, 30 degrees. Now the velocity in the x direction should be roughly 8.7 meters per second. And in the y direction, it should be 5 meters per second, roughly. Alright, so first we need to find the time. So we know that the arrow just fired towards the wall at a wall 5 meters away. So we get that the delta x equals 5 meters. So now, since we know the velocity in the x direction, 8.7, we can do Vx equals delta x over t. T equals delta x over Vx equals 5. Oh, sorry. Equals 5 meters over 8.7 meters per second. Now this should be roughly 0.57 seconds. Alright. So now that you have the time, we can now use the one of the big three equations. See, in the y. So delta y equals Vy naught times time plus half ay times squared. So let me just erase this part. So time is 0.57 seconds. So now we know that the initial, so we can now plug in the numbers for this one. So we get that equals 5 meters per second times 0.57 seconds, and then plus half times negative 9.8 meters per second squared times 0.57 seconds squared. Sorry if it's hard to see, but if you plug in the numbers, you should get that the delta y is roughly 1.3 meters. So now you can see that essentially how you solve these 2D kinematics problems is just basically splitting them up into individual 1D kinematics problems, and typically you have to solve for time, but not always. But time is also very important because time will be the same for both equations, right? So it can link the y equation to the x equation, right? So hopefully you learned something from this video. Please like and subscribe, and tune into next week for our forces video, and bye.